Remember the news channels reporting the temperatures for different cities for a particular day? It often reads like 23.2, 24.7 or 33.8 degrees Celsius. When we check our body temperature, the thermometer reads something like 98.6 degree Fahrenheit. The dots that we see in these figures are known as decimals. How do we get this decimal point and what does it mean? To understand this, let's recall the concept of place value that we have studied earlier. Ones, tens, hundreds, thousands, and so on. And what comes on the right side of ones? Fractions, 1/10th, 100th, 1000th, and so on. If we have numbers corresponding to first five places, say 7, 6, 5, 4, and 2, how are we going to write it? From ones to thousands, we know the numbers will be written as 7654. But what about 2, which is at 1/10th place? Now this number at 1/10th will come as 0.2. So the final figure becomes 7654.2. If the corresponding numbers were 7, 6, 5, 4, 2 and 4, the number would be written as 7654.24, where this 2 is the 1/10th and this 4 is 100th. If the numbers were 7, 6, 5, 4, 2, 4, 8, it would be written as 7654.248. Here 2 is 1/10th, 4 is 100th and 8 is 1000th. It is very important to understand the impact of placing 0 before and after the decimal. First, let's talk about something that we know already. If we have a number 5 and place a 0 on the right, it becomes 50. But if we place the 0 on the left of 5, it does not impact the number and it remains 5. That goes for all the numbers and figures. But in case of a decimal number, it is the opposite. If the number is 0.5 and we place 0 on the right of 5, it still remains as 0.5, as 5 is still in the 1/10th place. But if we place 0 on the left of 5 or between decimal and 5, the number becomes 0.05, which is smaller than 0.5. As we can see that in this case, 5 has shifted from 1/10th place to 1/100th place. So in case of decimal figures, placing a 0 on the right does not change the number. But if we place the 0 on the left, the number changes. Converting fraction to decimal. For converting fraction to decimal, let's take up a fraction 25/10. If the denominator is accompanied by 1 0, then we place the decimal after one digit from the right. So the value becomes 2.5. Had it been 25/100, that is 1 accompanied by 2 zeros, then we will place the decimal after 2 digits from the right and the value will become 0.25. If there is no digit before the decimal point, as a practice, we place a 0 there. So 0.25 will be written as 0.25. Now let's take another situation where the fraction is 25/1000. In this case, as per what we have learnt, we should be placing the decimal after 3 digits from the right. But we have only 2 digits in the numerator. So, what do we do in such a case? We will place a 0 as the third digit at the third place from the right and then place the decimal. So, our number becomes 0.025 or 0.025. In all these examples, it was easy to put the decimal as we had zeros in the denominators as 10, 100 or 1000. But what if we get a fraction like 2 by 5? How do we convert this into decimal? To begin with, we need to convert the denominator 5 into 10, which should not be very difficult, as 5 multiplied by 2 gives us 10. As we know, if we have multiplied the denominator with 2, we need to multiply the numerator also with 2. So 2 multiplied by 2 gives us 4, and our new fraction becomes 4 by 10. Now we can place the decimal one place from the right to get the decimal figure as zero point 0.4 or 0.4. So 2 by 5 is equal to 0.4. Now let's see how to convert decimal to fraction. Let's take the decimal figure as 12.5. For converting fraction to decimal, we begin by removing the decimal and make 12.5 as 125. As we have removed the decimal from one place from the right, we will write 10 at the denominator's place. We get the fractions as 125 by 10. If the number is 1.25, we will remove the decimal to make it 125 but place 100 at the denominator's place, as the decimal here was placed at two places from the right. The fraction that we get in this case is 125 by 100. Decimal on the number line. Let's take a number to plot on the number line. Let the number be 1.2. As we can see that this number lies between 1 and 2. So the area of action on the number line will be between 1 and 2. As the number is more than 1 and less than 2, let's divide the number line between 1 and 2 in 10 equal parts. Now let's label these parts between 1 and 2. It will go like 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and we have the 2 already. Now, after this subdivision between 1 and 2, we can easily see and plot 1.2, which is here. So first, we need to identify the two numbers between which the decimal number would fall. Then we subdivide the number line between these two numbers in 10 parts. We will find the exact position of our number with the decimal in that area. Now it's time to see how to check which decimal number is bigger and which one is smaller. Let's take two numbers 0.05 and 0.5 to understand this. We can compare these through mathematical solution by converting them into fractions first. 0.05 has two digits after the decimal. So we will have two zeros in the denominator, so it becomes 5 by 100. 0.5 has one digit after the decimal, so we will have one zero in the denominator, so it becomes 5 by 10. So the fractions that we have now are 5 by 100 and 5 by 10. As we know, to compare the fractions, we need to make their denominators same. The denominator of the fraction 5 by 10 can be converted to 100 by multiplying it with 10. And in that case, the numerator will also be multiplied by 10, giving the resultant numerator as 50. So this fraction becomes 50 by 100. Now we have both the fractions with same denominators as 5 by 100 and 50 by 100. Now we can see that out of the two fractions, 50 by 100 has the bigger numerator. So it is the bigger fraction. Hence 0.5 is the bigger decimal number. Another way of comparing would be to evaluate the numbers digit by digit. In this case, both the numbers have the same digit before the decimal, which is 0. So we move on to the next digit, which is the first one after the decimal. In case of 0.05, the 1 by 10th place has a 0. And in case of 0.5, 1 by 10th place has 5. 5 is bigger than 0, so 0.5 is bigger than 0.05. Let's take up another example. 25.65 and 25.6. In this case, both the numbers are same before the decimal. The 10th place after the decimal is also the same. In case of 100th place, the first figure has 5, but the second figure has nothing there. As we know that if we place any number of zeros after the decimal point, it will not change the value of the original number. So we can place a 0 at the 100th place here, which was blank. Now we have numbers at 100th place in both the figures. As we compare the numbers at 100th place, we see that 5 in the first figure is bigger than 0 in the second figure. So 25.65 is bigger than 25.6. Application of decimals. Money can be represented using decimal notations. It is common knowledge that 100 paisa is equal to 1 rupee. Therefore, 1 paisa is equal to 1 by 100 rupee, and 1 by 100 rupee can be written as 0.01 rupee in decimal notation. Let us use the decimal notation to write 455 paisa. We can split 455 paisa as 400 paisa plus 55 paisa. 400 paisa are equal to 4 rupees and 55 paisa is equal to 55 by 100 rupees. 55 by 100 can be expressed as 0.55. So 4 plus 55 paisa or 455 paisa is equal to rupees 4.55. Similarly, length can also be expressed in decimals. We know that 100 centimeter are equal to 1 meter. It implies that 1 centimeter is equal to 1 by 100 meters, which is equal to 0.01 meters. Let us use the decimal notation to write 745 centimeter in meters. We can break 745 centimeter as 700 plus 45 centimeter. 700 centimeter are equal to 7 meters. 45 centimeter are equal to 45 by 100 meters, which can be written as 0.45 meters. So 7 plus 0.45 meters equals 7.45 meters. With the help of decimals, we can represent weight also. We know 1000 gram is equal to 1 kilogram. Therefore, 1 gram is equal to 1 by 1000 kilograms, which can also be written as 0.001 kilograms. Now let us write 5450 grams in kilograms. If we make a split as in earlier cases, we will see that in 5450 grams there are 5 kilograms and 450 grams. So 5450 grams can be expressed as 5.450 kilogram. Addition of decimals. Let's recall the basics of addition. If we have to add 52 and 25, we will place 25 below 52 and solve. Here we place ones below ones and tens below tens and add. In case of the decimal values also, we will follow the same. For example, if we have 0.42 and 0.27 to add, we will place 0.27 below 0.42, ensuring that the decimal is placed below decimal, 1/10 below 1/10 and 1/100 below 1/100 and add. So our answer here is 0.69. This was simple. Let us now try to solve 4.35 plus 6 plus 52.4. As we can see that these are unlike decimals. So how do we place them for addition? The answer lies in converting them into like decimals. 6 can be written as 6.00 and 52.4 can be written as 52.40. Now our fractions read as 4.35, 6.00 and 52.40 and they are like. Now we can easily place them in vertical format and add. We get the result of this addition as 62.75. Moving on to subtraction of decimals. Let's subtract 45.376 from 642.25. The basic concept for subtraction of decimal remains the same as of addition. Place the digits according to their place value in vertical format. But as we can see that these are also unlike decimals. 642.25 has 2 decimal places while 45.376 has 3 decimal places. Writing 642.25 as 642.250 makes it the number with 3 decimal places. Now we can subtract them in vertical format. We get the result as 596.874.